Draw Lewis dot diagrams for sodium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. You'll notice that these are the elements that are basically sort of along the top of the periodic table for the most part, but there's one from each group. How you draw Lewis dot diagrams is real easy. You simply draw the symbol, so I'll start with sodium. There's a symbol for sodium. You look at what group it's in, and it's in group 1, and therefore has 1 valence electron. Lewis dot diagrams are only concerned with how many valence electrons you have, and so you put a dot there to show that one, and you're done. We look at beryllium, it's in group 2, Be, and you put 2 dots. It doesn't actually matter where you put them as long as there's 2. Boron, group number 13, but we know that means it has 3 valence electrons. Carbon, group 14, 4 valence electrons. Nitrogen, group number 15, which means it has 5 valence electrons, so 1, 2, 3, 4, 5. Oxygen, 1, 2, 3, 4, 5, 6. Fluorine, halogen, has 7 valence electrons, so we draw 7 dots. 1, 2, 3, 4, 5, 6, 7. And then neon has a full valence shell, noble gas, with 8, and so we draw 1, 2, 3, 4, 5, 6, 7, 8. And there are our Lewis dot diagrams for one from each group element here. So we want to draw a Lewis structure, let's say, for this is what we use for molecules and compounds. We would say that Cl2 is chlorine gas. So how using a Lewis structure, we can see how that would bond. So if we draw 2 chlorines here with our Lewis dot diagram, so 1, 2, 3, 4, 5, 6, 7. And then we draw, since there's Cl2, we need another one. 1, 2, 3, 4, 5, 6, 7. Note how I sort of made it like a mirror image of itself with the 2 dots sort of lined up here. And why I do that is so that we can see that these are the 2 that are going to be shared. So that's the bonding capacity of 1, which means we need, or each of these chlorines has 1 electron to share, and that now gives 2, 4, 6, 8. 2, 4, 6, 8, and so the chlorines are satisfied, and we draw those shared electrons as a line. We include the other ones, and there you have it. We do the same thing for something like oxygen and nitrogen, but that will show us double bonds. So if I do oxygen first, I'll do the same thing, draw the Lewis structure. 1, 2, 3, 4, 5, 6. And I'll do the same thing again, 1, 2, 3, 4, 5, 6. Again, note how I sort of made it a mirror image of itself, and that shows that these can go together and these can go together. If you don't make them a mirror image of one another, it's harder to link the 2 up. And so the Lewis structure will look like so, meaning we have 2, 4, 6, 8, and 2, 4, 6, 8 electrons for each, so they both are satisfied. Nitrogen will be very similar. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. These will bond. There's a bond, and there's a bond. So in the case of nitrogen, because it has a bonding capacity of 3, it can form a triple bond, and we still have all 8 electrons. 2, 4, 6, 8. Or 2, and then 2, 4, 6, 8 for the other one. So both have 8, and everyone's satisfied.